Hi everyone, welcome back to the channel. Today we're going to conclude the third video of the three-part series on Solana custom tokens. So we started this series by effectively creating our own custom token. In this case, for the e-commerce platform, I decided to create a token called the MAIA token. And in the first video, we basically covered everything that you require to actually create that token. We used primarily the Solana CLI and the Token CLI tools directly from the command prompt to create the MAIA token in this case. I've shown you in that first video, which basically is 2 videos ago. I've shown you how to create the mint address, the mint authority, how to create the token metadata, all of that stuff. So if you want to know more about that, please go to that video, which is basically 2 videos ago. Yeah, you should have everything you need there, including one user actually commented on the video saying that they found most useful the information about the picture requirements for the logo for the coin. And as I said, I was thinking that that was like just a side note, and in fact, it was useful for someone. So I'm glad that that was the case. The second video was primarily about the back office application, and this is what I wanted to show you here. So I've shown you this diagram a long time ago. So when one of my first few videos about the Solana smart contracts and the front end development code, I've shown you this diagram, but now I've updated it to actually include this element here. So the diagram is all the same except for this piece here. And as you can see here, so I added the back office app, which is effectively was what I created for the second of the series video. So last video. So this is the content of last video was about this back office app, and in that video I basically described why I decided to create this back office app, and the architectural decisions that went along with it. It was uh, the one-line short summary is it was primarily driven by security, but also scalability. But if you want to know more details about that, of course, I encourage you to watch that last video, which is part 2 of the 3-part series. And yeah, in that back office app, like the summary is that the app basically is used to listen for WebSocket events from the Solana blockchain, and it listens for very particular events that are associated with our program, so our smart contract. So in this case, the MAIA Soulful Sellers smart contract is basically triggering the creation of certain data accounts, which are the purchase order data accounts. So every time every time a new purchase order is created in the Solana blockchain by a customer, when the customer purchases bottles of wine or any other good, but in this case it's bottles of wine, effectively that triggers the creation of this metadata associated with the transaction. And what this back office application does is effectively listens for those very specific events. It filters out everything else. It doesn't care about the other events that the program generates, but it just basically just is listening to the purchase order creation events. So as soon as it detects a relevant event, it basically triggers the MAIA token distribution. So effectively, it rewards the customer by allocating a certain number of MAIA tokens and drops them into their wallet. So this is effectively a very, very slick and efficient way of decoupling the MAIA token distribution code from both the front end as well as the back end. And this was effectively the topic of the last video. Again, not going into more detail on that. If you want to know more about that, as I said, please watch that last video. In today's video, and I just wanted to show you like the whole picture now because I think it makes more sense now that's why I kind of decided to update the picture to show you this. In today's video, what I'm going to show you is this app, this architecture has now been updated. So I created I updated an existing view, which is the order confirmation screen view that effectively what the order confirmation view is now showing the customer a slider bar where the customer can adjust to say, I want to spend these many MAIA tokens in order to get a discount on my purchase. And then you can, the customer can use the slider to basically say whether they want to use, let's say, 0% or 50% or 75% or 100% of their MAIA tokens to obtain, for instance, if they go for 100%, they're trying to get the maximum discount possible. And in doing so, not only they get the reward, but as the purchase order is triggered, there is a new reward happening as a result of that purchase order. And so, yes, the app has been updated to not only fetch the balance, the existing MAIA token balance. So I'll show you the code that does that. The UI obviously has been updated to show the slider, but it's also been the code. The most interesting element of the code, I believe, is going to be how do you encode a transaction for the Solana blockchain, because when the purchase order is placed, now there is another instruction that might need to go into the transaction, in the transaction that gets approved in the wallet and then sent into the Solana blockchain, which is effectively to do with these MAIA tokens. And again, I'll show you that in the code. So I'll start with the demo first, because I think the demo will be bringing everything to life. So I will show you the whole, and this demo obviously will cover demoing what we discussed in the last video in the back office app element, but it will also show you the interaction in the front end. And as a result of our actions in the front end, the events get triggered in the Solana blockchain. So that as the purchase orders get created, the WebSocket events are fired. The back office application that is listening for those events catches them, and then effectively then triggers the MAIA token distribution and drops them into the wallet of the customer that actually executed the purchase. So this brings the whole thing, closes the whole loop. So let's start with the demo. So I'm going to go into the demo screen, and let me just clean this for now. And I will, let me just actually do this. So, sorry, it took a few seconds to load this. So as you can see here, there is this, the first message that you get, like, so this is after you register to listen for events, you get your first sort of response from that WebSocket channel, and that is the acknowledgement of by Solana that your registration to listen for events from your program has succeeded, and they give you the subscription ID so that you can cancel the subscription at a later stage if you wish to do so. So let's buy some wine, shall we? And then you'll see things happening. So if I now go and let's say buy one bottle of this one and one bottle of white, and then I do a place order. So I'll need to, actually I didn't order this one yet, so I'm gonna have to put the my new address. I didn't enter a shipping address yet on this account, so sorry about that, but we'll do that. So this is going to ask me to create that order, which it did. As you can see, this created nothing because that account is not updated, it's not creating a new purchase order, so that's why you didn't see anything here. So now, as you can see, it's basically saying, you know, for these two bottles, how much of your MAIA token do you want to use? As you can see, there is some MAIA tokens that I already had from previous tests that I've done. So I have 1.2. So if I go back here, and if I say I want to use 50%, so that's 0.62, I place the order. And as you can see here, so it's basically saying it's going to cost you 0.45 SOL and 0.6 MAIA tokens are going to be debited from your wallet. So remember that 0.45, so you say confirm. And there you go. So as soon as I've done that, see, notice how fast that was. But as you can see here, the purchase order was created. You can see that it's that wallet there. So as you can see, it starts and ends with that, with those exact letters and numbers. You can see that I bought two bottles, which is what you see here, 0.45, which is the total price. And as you can see here, I printed basically that the MAIA SOL, the MAIA token to transfer is 0.45 because in my logic, I basically just said, I want to transfer the same amount of MAIA tokens that the customer spent in SOL. So if the customer spent 0.45 SOL, I want to reward them with 0.45 MAIA tokens. That's simple. So I wanted to just a very simple logic so I could trace exactly everything that was happening. And as you can see here, it basically says that the ATA, the associated token account, that where the tokens are coming from, they are coming from the Mint Authority ATA account, and this is the transaction signature, the transaction ID effectively, and then you have this printout basically saying that there was a success transferring that MAIA token to that wallet, and this is the new ATA account. Well, it's not new because it already existed, but if it didn't exist, it would create the new ATA account. So that can also, so this is very, very simple. We can do another one. So in this case, for example, I'm just going to buy one bottle of red. As you can see, it didn't ask me for the shipping address anymore because it already knows it. And now I'm not going to spend any MAIA tokens. So as you can see here, I do have some MAIA tokens, 1.0, but I'm not going to spend any. So I'm going to say place the order. And now notice that it's not debiting MAIA tokens anymore. It's only debiting SOL, 0.3. As you can see, very, very quick, 0.3. And now if I go to my wallet, you'll see that I have 1.3. So you remember we previously had 1.0. Because we spent 0.3 Sol, we got rewarded 0.3 MAIA token back. What that means is that now we have a total of 1.3 MAIA tokens, which is exactly what we expected, right? So I think that's enough for a demonstration. By the way, what I do want to show you also is the transactions that got triggered as a result of this. So if I go to this and I show you the transaction history, here we are. So in here, as you can see, we have the token 2022 account, which is effectively for the token mint authority, and for the token that we created, which is this is the mint address of the token. So if you go back to, if I refresh this page, you'll see these transactions here, right? So these transactions were our transactions just now. So if I click on one of these, for example, this one here, you will see the 0.3. Do you remember this one that we just saw on the demo that I was just running? So you can see that the token mint authority was debited minus 0.3 MAIA tokens, and this ATA account, which is effectively the ATA account of the customer's wallet, was credited with 0.3 MAIA tokens. This makes perfect sense, right? So it's exactly what we expected. The tokens were transferred from the mint authority to the customer's wallet address. So now that we have this, let me just check, go back to here, and I want to show you the code now. So let's talk about, let's see the code that does exactly everything that you just seen. All right, so first I'm going to show you the code that actually, I'm just going to stop the application now. So I'm going to show you the code now that actually does the fetching of the MAIA token balance from the DApp. So as you can see here, this code is actually super simple. You'll see that I didn't actually need to do any of this. So this element here is really not necessary. I only did it because I wanted to demonstrate to you. So in the final code, before I go to production, I will actually remove this because this is not really needed. But anyway, for demonstration purposes, I just wanted to keep it here for completeness. As you can see here, with this instruction, with this RPC, get token account balance, I'm passing the ATA of the token mint authority as the argument, and as a result, I get the token remaining supply. So this is a way for you to get how many tokens you have left that you've not distributed yet. Very simple. And this is just formatting for the tokens too, because when you get these numbers, they appear with the 9 decimal places. And I wanted to show in the human readable way. It's the same thing with Sol, right? So you can see Sol in Lampports, which is a billion, in the billions kind of Lampports, if you're talking about 3 Sol or 4 Sol or something like that. And it's the same thing with our tokens, right? It works exactly the same way. So now this is the interesting part. So this is basically, so how you get your token Mint Authority's remaining balance. But this is not really the interesting part. The interesting part is this one here. So you know what this function does is it gets the customer's public key, wallet public key as the argument, as a string. And what I do is I first create the public key object associated with that string. In Dart, it's this one that I'm using, but in your programming language of choice, there will be an equivalent probably object that you need to parse the string and then create that public key object. And this one, for example, is from the Solana package for Flutter Dart. Again, in your programming language, you might be using a library that is appropriate for your language. And in this case, I didn't have to change anything. So I've told you in the previous video that I had to correct some of the library's functionality because it didn't work as expected. So there was some methods from that library that I couldn't use directly. So I had to go at a more granular level and understand what the library was doing. Fortunately, for this video's context, I didn't actually have to do that, so that's great. So all of the methods that I'm showing you here actually do work perfectly. So, but you know, so again, I'm expecting that in your libraries, in your programming language of choice, be it JavaScript or something else, you will have obviously similar methods that do similar things to this one. So let's analyze what's happening here. So in this case, I am deriving the address of the token ATA account for the user, for that public key. How do you do that? So I covered this in the previous video, but effectively it's the same as the same explanation as before. So you find the user's associated token account by basically calling this find associated token address. And what this does, it needs some seeds. So you remember how you derived PDA addresses? Again, a topic that we covered in previous videos. This token ATA account is a special kind of PDA address. So this is exactly, you're passing some seeds into it and then generating a new address based on those seeds. The seeds are the customer wallet, the token mint address, and the token 2022 program ID. So you pass all of these things in here, and then what you get in return is a derived address, which is basically the user's ATA account. And this is deterministic. As long as these things, you always pass these things in that correct order, it will always generate the exact same address. So as you can see here, what I'm doing now is I am basically saying, get me that user's MAIA token balance. So that's what I'm doing here. So I'm using the Solana RPC client that for Dart, and then I'm calling the RPC method get token account balance, and I'm passing in the derived address that I derived using these seeds in the previous step. So nothing too complex or groundbreaking. Then what I do is I convert this into a double type from a string. And what I've learned is that the amount that is returned, it's returned as a string type. So I have to obviously convert it into an appropriate type. And in this case, the amount, again, as I said, has 9 decimal places. I will need to check whether this is sufficiently large to not truncate, but you know, that's something. So whenever in these data type conversions, you always have to pay attention to how to whether the type that you're using to receive the parsed data is large enough to accommodate that data, because we're talking, like in this case, it has 9 decimal places. It's quite a large number. So you want to make sure that the data type that you're using and the conversion process that you're using is actually not going to create problems and truncate the number in any way, shape, or form. And very, very simply, I'm just printing out the customer's balance and I'm returning the customer balance. One of the things that, as you can see here, that I've written here is handle cases where the ATA account might not exist or have zero balance, because I am obviously assuming that, well, the code, in order for the code to be completely robust, you need to account for these exceptional cases, even if you think they can never happen. But I, I want to make sure that I don't forget to do this. So that's why, I sprinkle my code with to do, and then in the end, I'll just resolve all the to dos that I have. So yeah, it's a technique that I typically use. So that's the get MAIA balance, and the code is very simple, but I just wanted to demonstrate to you how to get your remaining tokens from your token mint authority, and also how to read the MAIA token balance from the user's wallet. This is how you do it. You derive the address and then you call the RPC method get token count balance. Super simple. And this is basically then what's used when you saw in the demo that I gave you earlier, the slider with the number of MAIA tokens to be consumed. This is exactly the number that is being passed to the UI, so that the UI displays the correct amount of MAIA tokens that the customer has whenever the screen is rendered. So yeah, that's it. So let's talk about the last element of this, which is the code that allows the customer to spend the MAIA tokens, right? So this is the final element to close the loop on the whole process of not just distributing tokens, but also spending the tokens. So as you can see here in the create purchase order, this is quite a big method. There is a lot more code in this method, but what I wanted to show you is just the portion of the method that is relevant for what we're trying to achieve, which is the new code that I added to actually enable the application or enable the customer to spend the MAIA tokens that they were awarded in previous purchases. So as you can see, I first start by creating a list of an array of instructions, or a list of instructions. As you can see here, there is the Solana Web3 transaction instruction. It's a special type that was already included in the library that I'm using. Again, in your programming language, if you're not using Dart, there will be something similar to this. And then what I'm doing is I'm saying if the MAIA tokens consumed are greater than 0, and if you remember in the demo that I've given you, the customer might choose to not spend any MAIA tokens. Just as a side note, one of the things that I'm planning for the MAIA token is that the MAIA token's value will be closely tracking the Solana appreciation. So I could see scenarios in the future where people might want to not spend their MAIA tokens because they're valuable and they accrue value over time. So this is a quite kind of an interesting logic. That I've been kind of playing with it in my head, but effectively, the longer they keep their tokens in the wallet, the bigger the discount they'll get in the future. So yeah, it's going to be interesting, and obviously as Solana appreciates in value, the number of tokens that they get are less. So if you're an early customer that makes a lot of early purchases, especially in the bull market, you'll get a lot more tokens than someone that buys a lot later. So anyway, it's an interesting dynamic that I'm kind of playing around with it. The world of customer loyalty and rewarding customers with blockchain technology and custom tokens on Solana is full of possibilities, and there are so many things, so many cool things that businesses can do in the future. But anyway, sorry, I was just going off on a tangent, but um, all of this was triggered because of the fact that we are talking about this condition check here, saying if my tokens consume greater than zero, because again, customer might choose not to spend their tokens, and they may have good reasons to not want to spend their tokens. But if they do choose to spend some tokens, then I say, I print out to the console, customer decided to consume these many tokens, and the next thing I do is I create the MAIA transfer instruction. So the instruction that again takes the tokens from the token mint authority. Sorry, in this case, it's not that. The instruction that takes the tokens from the customer's wallet and then sends it back to the token mint authority account. So they return to the mothership, so to speak. So this is, I'll show you what this function contains in a minute. This is the whole point, or the most important element of this video, which I'm going to show you in a minute. So it creates the MAIA instruction, and as you can see, I pass the arguments is the user public key, and I pass the amount to transfer. Makes sense. So I'm just saying for this user, I want to transfer these many tokens, which is basically what the user selected on the slider. And then I'm creating the instructions array. And as you can see, so in previous videos, you probably must have remembered that, in one of those videos, I've shown you this exact same code. Obviously, it didn't have this because I didn't have my tokens at that point in time. But now, what that video probably, you remember that from watching that video, this was like several videos ago. I only had these two. So instructions were the transfer instruction and the purchase order instruction. Just recalling very quickly, remember, Solana transactions are like database transactions. And the transaction is a collection of contains a collection of one or more instructions. In this case, for example, whenever a transfer is done, because you're purchasing bottles of wine, a certain number of SOL is taken from your wallet and it's transferred to the target wallet to process the payment. Now, whenever that happens, I create a new Solana data account to record the metadata associated with this transfer, which is effectively the purchase order data account. And this is what you see here. The purchase order instruction is going to create a new account to store this purchase metadata. Now we're adding a third instruction to this transaction, which is the MAIA tokens spend as a result of the customer trying to get that reward. So as you can see, this is a transaction which now is having like 3 different instructions to be done. And this is great because, as you can see, the other thing that you should notice is that you have multiple programs, the system program, our smart contract, the token 2022 program. So there are, 3 or more different programs being called in this transaction. And it's really, really interesting because this shows again the Solana's incredible sort of composability, because you can call, not only you can call from a certain instruction, you can call other programs instructions. So this is the cross-program sort of invocation sort of element of it. But it's also the fact that because you can package a number of instructions within a transaction, those instructions can call multiple programs and multiple instructions within those programs. And this is all done seamlessly behind the scenes. And obviously the whole thing only, it's like if one of these fails, then the whole transaction fails. But if one and all, and none of the side effects happen, right? It's all, it's all kept consistent. And again, but if all of the three succeed, then the transaction is considered successful, and then it's added to the blockchain as finalized. Again, I covered all of these topics in previous videos, how transactions work and the anatomy of an instruction, etc. But I just wanted to, it's pertinent in this context to bring it up again. And then, as you can see, if the customer decided not to use any MAIA tokens, therefore the transaction will only contain actually 2 instructions, but so it's a transfer instruction as normal to transfer the SOL for the payment and the creation of the purchase order metadata. But it does not include the MAIA instruction, of course, because there is nothing to spend. Right? I'm not going to cover any of the rest of the code because, again, I've covered this in previous videos. So if you want to know how that works, please go and check them out. Now, for the final part of this video, I'm just going to show you the create MAIA transfer instruction, which is this one here. So I'm going to, here we are. All right, so this is the core of this video. So let's get to it. So it receives by argument the string, which is the customer's wallet public key, and it also receives the number of MAIA tokens to be spent. One of the things that you'll see, I have hard-coded here the mint authority associated token account. So it makes sense that we would keep it hard-coded because this is, this is not going to change. It's always going to be the same account that we want to receive the tokens on. The mint address, again, not going to change. Obviously, we probably wouldn't want to keep this here. One of the things that I'll do to clean up the code is transfer this to my constants that had it's a Dart file that has all the constants of the entire application. So these are definitely good candidates to go in there. But anyway, so this is just quick and dirty just to demonstrate the functionality. So you have the mint authority, you have the mint address. Then I create the public key object for the wallet address and also for the mint address. Then I go and find the customer's ATA address. So find associated token address. This is exactly the same as before. So we've already discussed how this works. So we find out the derived address for the customer's wallet, for the ATA for the customer's wallet for this particular token, which is the MAIA token. That's what that MAIA customer ATA is. And now here is the how you encode a Solana transaction, sorry, a Solana instruction to spend your custom token. So this is it. This is the key thing that you need to really do well. So let's look at this in detail, because this is, if some of this is messed up, the transaction is going to fail, believe me. So The keys. So remember, the instruction always, one of the things that the instruction always sends is a list of accounts that are going to be, which is in this case is the keys array. It's always going to be either accounts that you're going to read from or write to, and that's going to be indicated here. So the first one that goes in here is the MAIA custom ATA. So this is the source where the tokens are coming from. And as you can see here, this is not a signer. So the ATA accounts never sign anything because that's not the purpose. Like those are PDA accounts. Remember, PDA accounts, they don't have the ability to sign anything. So these are just typically data accounts that are read from or written to by the programs. So that's why they don't sign explicitly. So that's why e-signer is false. But it's writable. Yes, of course it is writable because I'm now going to debit some tokens from that account. So therefore, it will have to be updated. Therefore, that's why it's writable. Now, the destination. The destination is the Mint Authority's ATA. So I'm going to actually send the tokens back to the, as I said, the mothership. So the tokens are going to return to the Mint Authority ATA. And as you can see here, same as before. So I am saying create this account method object type, which basically is the Mint Authority's ATA. And then I'm saying is signer again false for same reason as before, and is writable true for same reason as before, because now I'm going to update, I'm going to drop some tokens into that account. Finally, we have the customer's public key for signing via Phantom. So this is really important because now this is the actual wallet address, and I'm sending it here to say this is actually going to be the entity that is going to be signing approving this instruction effectively. So as you can see, now, because it's the wallet address, so previously it was the ATA address, which is not a signing entity, but this one is a signing entity. So this is why e-signer is true and is writable is false. Again, because this is not going to be changed. This account is only signing. It's not like the what's changing is the ATA associated with that wallet. So the program ID. Oh, and by the way, one of the things I think someone mentioned, asked me the other day. Oh, but it changes because there are fees that are debited and there is sold, but that's different. That's not. That doesn't count in this particular instance. So then you have the program ID. So you have token 2022 program ID. Effectively makes a lot of sense, right? Because we've been using token 2022 to create the custom Solana MAIA token. So the custom token that we decided for our application. So we've been using that program, so it makes a lot of sense that actually we are calling these programs transfer sort of instruction. So that makes total sense. And then finally the data. So this is really important. So how do you create this? So you create a byte array where you add two things. One is the transfer index. So this is effectively saying within the token 2022 program, which instruction should I call? And this is the one that you're calling. You're calling the transfer instruction of that program, of the token 2022 program. And then you're passing on some arguments into that. And in this case, you're passing the argument, which is the MAIA amount to spend, to send to the token mint authority. So that's it really. So I'm going to just recap very quickly. You create an instruction which is going to be part of a wider Solana transaction, which we've seen in our case is 3 instructions long. And this create MAIA transfer will have an array of accounts in which you have your source ATA, you have your destination ATA, and you have the signing wallet. Then you say that the program ID that you're calling is the Token 2022 program, which makes a lot of sense because that's the program under which we created our MAIA token, and it's where the accounts exist. The accounts like that have the balances exist. And then we are saying with the data always includes 2 things. The data includes the method, i.e. the instruction within that program that is being called, and it contains the, the arguments for that instruction. So the arguments are, in this case, the amount of MAIA tokens that are going to be sent from the from address to the destination address. That's it. So that's it really. I think I've covered everything that I needed to cover in this video. So we've completely closed the loop on the whole how to create a Solana token, custom Solana token for your decentralized application. As I said in the beginning, we started by creating the token on the first video. Then in the second video of this 3-part series, we implemented the back office application with the WebSocket code that kind of listens for events and triggers the MAIA token distribution. And then on this video, in this last video, we talked about the code that sits in the DApp frontend. So in this code, we effectively fetch the MAIA token balance from the associated wallet, the wallet that is logged in the app. And we also have the code, this code, which effectively sends the transaction to the Solana blockchain that includes 3 instructions: transfer the SOL for payment, create the purchase order for the for the metadata to be associated with that transfer, and then finally the instruction that calls the token 2022 transfer instruction for the specified amount from the source to the destination, and the customer is the one that is going to sign. And we've seen this in the demo of the app that I've shown you, where in the first example that I gave you, you saw the SOL being debited and the for the payment of the purchase order, and also the MAIA tokens being debited. But I've also shown you an example where I decided not to spend any MAIA tokens, in which case you only see the SOL being debited but no MAIA tokens being taken. And it kind of is shown very nicely in the pop-up that is shown. That's it. I hope you've enjoyed this 3-part series videos on creating Solana tokens. If you did enjoy this video, please consider dropping a like. Please subscribe also to the channel so you get notified when I drop my next one, and hit the notification bell. I hope you comment on the section below, basically saying, if you've had any challenges following the instructions that I gave you on this video. If you do, please let me know. I'll try and help as much as I can. And yeah, my friends, stay empowered, stay decentralized. Thank you very much. Goodbye.